So in this video, we're going to be talking about covalent bonds. And in a covalent bond, that's when we share our electrons. So one atom doesn't give up or gain electrons, they're going to share so that both of their outer energy levels are full. Typically, covalent bonds occur between a nonmetal and another nonmetal. So it is nonmetal to nonmetal. Okay, so unlike ionic bonds, they were a metal and a nonmetal. This is two of the same kind of element. Both are nonmetals. There are three types of covalent bonds that we can have. The first one that we have is called a single bond. And so I'm going to demonstrate that with fluorine. So fluorine bonded to itself. If you recall, one fluorine atom has 7 valence electrons. And so I'm going to draw my second fluorine in a different color to show the difference. Okay, so what they're going to do is this fluorine has an empty space there, and this fluorine has an empty space there. Now we can't give up this electron or give up that electron, but what we can do is we can share it. So these fluorine atoms are going to share this electron, and it's going to look like this. If you draw a circle, now in the blue circle, if you count the electrons, I've got 1, 2, 3, 4, 5, 6, 7, and 8. So that fluorine atom is happy. And so then I'll draw another circle around this fluorine atom for all of its electrons. And again, we'll count them up. I've got 1, 2, 3, 4, 5, 6, 7, and 8. So that fluorine atom is also happy. And you can see here they are sharing one pair of electrons. So when these, during these covalent bonds, when you share one pair of electrons, that is called a single bond. So that is one pair or 2 electrons that are being shared. Another way that we could write this is, if I move that down a little bit, I could have my fluorine bonded to my other fluorine. We could draw a dash like that, and we still have to draw all the other electrons. So this line here is representing these 2 electrons that are being shared. So whenever you see a line drawn like this, that's one pair or 2 electrons. So again, you can still count them up. You have 1, 2, 3, 4, 5, 6, 7, 8 for that fluorine, and then 1, 2, 3, 4, 5, 6, 7, 8 for that fluorine. And still everybody's happy. So again, this is a single bond where we are sharing one pair of electrons. On this slide we have oxygen. And so let's just revisit what oxygen looks like. So the symbol's O, and it's in group 16, so it has 6 valence electrons. Now, if you recall in the last one we had fluorine, which has 7 valence electrons. And an easy way to figure out how many bonds an atom is going to form is to look at how many electrons are unpaired. So if we're looking at fluorine just real quick, we can see I've got a pair of electrons here, I've got a pair here, and then this electron is by itself. So that electron is going to want to form a covalent bond. So fluorine is really good at forming single bonds. If we look at oxygen, I've got a pair here and a pair here, and then I've got this one that is alone and this one that's alone. And so oxygen wants to form 2 covalent bonds. 2 covalent bonds. So if it bonds to itself, it's going to form what's called a double bond. A double bond. And so let's get rid of this fluorine here. So I'm going to have that oxygen drawn up there, and I'm going to leave that there, and I'm going to redraw a new one down here for bonding purposes. So here we go. I kind of drew those 2 electrons that are by themselves kind of off to the side, just so it's going to be a little bit easier when we show how they are bonded to the other oxygen. So then my other oxygen I will have here. And I'm going to draw this one in a mirror image, again, just so it's easier to show the bonding. So here is for that oxygen. Just count them up. 1, 2, 3, 4, 5, 6, and 7, 8. Okay, I've got 8 electrons. Remember, 8 is our magic number. That's how we know our valence shell is full. And then in this one, we're going to have, there you go. So you're always going to look at the electrons that don't have a friend or a pair. So if I'm looking at the Lewis dot diagram for oxygen, this electron and this electron are going to be involved in bonding. So if it's bonded to itself, you know that they're going to bond together. And so this is called, when we're sharing 2 pairs of electrons, that's called a double bond. Again, that's 2 pairs or 4 electrons that are being shared. And so we can redraw this like we did with fluorine. A double bond is going to be 2 lines that are drawn, and then we're going to put those other electrons just on the ends. And so the electrons that I just drew here are these electrons that were already paired up. Okay, those are the same electrons. So we just have to make sure that we're drawing those still. We don't want to leave those out. And then there's something to note about a double bond is that it's actually a stronger bond than a single bond. So as we move up in the bonds, they're going to get stronger and stronger. So the more bonds we have, the stronger it's going to be. Okay, so that's a double bond where we have 2 lines. So remember, each line represents 2 electrons. And so this is 2 electrons, and this is 2 electrons. So total there we have 4 electrons that are being shared. And the last bond that I'm going to go over is a triple bond. And so nitrogen is really good at forming a triple bond. If we look at the Lewis dot diagram for nitrogen, it's in group 15, so it has 5 valence electrons. And so I can see here I have a pair at the top, so they're not going to be involved in any chemical bonding. The electrons that are going to be involved in bonding are this one, and this one. So we can see that because it's got 3 lonely electrons, it's going to form 3 bonds. So nitrogen is going to bond to itself. It's going to form what we call a triple bond. So, and I'm going to redraw this Lewis dot diagram. I'm going to break a little rules here just so it's easier when I'm drawing, when I'm showing the sharing of electrons. Okay, so I'm going to take these 2 electrons that I have up here and I'm going to move them to the side. Again, this is just going to make life a little bit easier when we're drawing the diagram here. And then these 3 electrons that are going to be involved in the bonding, these 3 lone electrons, I'm going to put them in the middle, like in the middle of where my drawing is going to be. This is just to make life easier. Okay, and then my other nitrogen is going to be the mirror image of that. There you go. Okay, and so I'm going to circle my electrons, count them up, make sure we've got 8 in the circle. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 electrons, we're good to go. We do the same thing for the other nitrogen. So count them up. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. Everybody's happy. And so this is called a triple bond. We're going to share 3 pairs of electrons, or 6 electrons. And then to show that, when we redraw that, you draw 3 lines, and then draw your other electrons. And so the 3 lines, remember each line is 2 electrons. So 1, 2, 3, 4, 5, 6. So a triple bond, sharing 3 pairs or 6 electrons. And this is going to be the strongest of the covalent bonds. So this is the strongest bond. So the more bonds you have, the stronger it's going to be. So I'm just going to go through a few more examples with you and talk about a couple of special cases. Okay, so our example is carbon chloride. So the first thing we want to do is we want to look at the Lewis dot diagrams. And so carbon, it's in group 14. So I can see it here, group 14. It's going to have 4 valence electrons. Okay, and chlorine, it's in group 17. It's a halogen, so it will have 7 valence electrons. So looking at carbon, I can see that carbon has 4 electrons that are all single. They don't have any electrons that are paired up. So that means that carbon is going to form 4 covalent bonds. If I'm looking at chlorine, chlorine only has 1 electron that's unpaired, so it's only going to form 1 bond. But that's okay, because if I look at my formula, I can see that I have 4 chlorine atoms involved there. So when you have a formula like this, usually the first element goes in the center. So this is going to be the central atom. So carbon we're going to put in the middle with the 4 electrons that it has. Okay, and then chlorine, we're going to put chlorine around carbon so that we can match up our electrons. And I'm drawing that empty electron, or that lonely electron, just so that my life is a little bit easier when I am drawing my circles or my showing how the electrons are shared. So I'm going to start with carbon in the middle. So I'm going to circle the electrons on carbon and the lonely electron on each chlorine so that everybody's sharing and everybody's happy. So those two, those two, those two, and those two. So if I count all the electrons in that blue circle, I have 2, 4, 6, 8. So we're good. And then for chlorine, I'm going to change the color here a little bit. So make it green. So in the green circle, 2, 4, 6, 8. Very good. Same thing here, here, and down here. Okay, 2, 4, 6, 8. So everybody's happy. So another way to draw this would be so we've got carbon. Remember, those lines represent 2 electrons each, and my chlorines. And then don't forget to draw all those extra dots on chlorine. You have to do it. It's kind of a pain, but we need to show that they're there. Okay, and there is your structure for your covalent bond for CCl4. And also, just real quick, this would not be called a quadruple bond, even though there are 4 bonds here. They're all single bonds. So if I'm looking at the electrons that are shared here, I've got 2 electrons in this middle of this chlorine and this carbon atom. And so this is a single bond. Same thing here between these 2 elements. I've got just 2 electrons that are being shared between these 2 elements. So it's another single bond. Same thing here, same thing here. So I have 4 single bonds. Okay, this is not a quadruple bond. That's not a thing. So this is 4 single bonds. And then also we'll get into naming later, but this would be carbon tetrachloride because tetra means 4. It's a prefix that means 4. But like I said, we will get into the naming a little bit later. And so for our last example, we have NH3. So I chose this one because we need to talk about hydrogen, and it does some special things when it is involved in covalent bonds. So let's look at nitrogen first. And remember, nitrogen is listed first, so it's going to be in the center. So nitrogen, it's in group 15, so it's going to have 5 valence electrons. Okay, and we can see that it has 3 electrons, 3 electrons that are not paired. And so it's going to form 3 bonds which is good because I've got 3 hydrogens I need to put in here. If we look at hydrogen, we can see that it has 1 valence electron. And that's all it has. But if you recall, hydrogen is in period 1. Okay? So that means it only has 1 energy level. And remember, how many electrons can fit in that first energy level? Only 2. So hydrogen and helium are the 2 exceptions to our magic 8 number. They only require 2 electrons to be satisfied, whereas all the other elements want 8 electrons. And so hydrogen and helium only require 2. So hydrogen, you don't have all those extra electrons like we did for chlorine. And so I'm going to draw my 2 other hydrogen elements. And there we go. So nitrogen still wants 8. So you can count all the electrons there in that circle, and that's 8 of them. Okay? And then when we do hydrogen, we circle those, and we can see they only have 2 electrons in their circles. But remember, that's okay because hydrogen only needs 2. Okay, because that first energy level can only hold 2. So hydrogen is the exception to that 8 rule. Okay, all the other elements are trying to get to 8, all the other nonmetals. Remember that a covalent bond is between 2 nonmetals, at least 2 nonmetals. Those nonmetals could be the same, like with fluorine and fluorine, oxygen and oxygen, nitrogen or nitrogen. And we can have other examples like CCl4 and NH3. Those are also covalent bonds because the only kinds of elements that are involved are nonmetals. Okay, and then let's just draw this. Let's finish this up here and just draw this, the structure. So we're going to have nitrogen with its 2 electrons, and then the 3 hydrogens are going to come off like that. And remember that this line here is representing 2 electrons, so a pair of electrons with that line. So that's NH3. And there you go. That is just a quick intro on covalent bonding.